working on a tutorial titled Volumes, Grids, and 3D Modeling, which is going to take you through the basic process and some commands that you'll be using as you work through Project 1. The first step in that is going to be, we're going to be working on some volumes. And to do that, you'll want to, number one, make sure that your Rhino document is set in the proper units. And I know that you guys have worked in Rhino for the purpose of line drawing, so I'll sort of breeze through the first couple of steps because you'll be pretty familiar with it. The first step to setting units is typing in units and then opening up this directory, which will be a little different for Macs. And you'll select feet because we'll be working predominantly in feet today. And then you'll press OK, and it might have to rescale some stuff, but in a blank Rhino document, it doesn't matter. So that will lead you to an empty Rhino document. The next step is, once you've selected or been assigned your painting from which you'll create a 3D geometry, you'll load that into your Rhino document using the picture frame command. And these are all the different volumes. I've selected this one because I think it's sort of fun, but I'm also going to load in, let's see, I'll load in this one as well because we'll model this one because there's some other commands that we'll need to use to model this one. And I think other than that, that's it. This one, oh, this one might, let's do this one as well. So we'll model all three of these. So the important part, because we're going to be working with grids, is we'll want to keep our geometry constrained to even whole numbers. So no like 15 feet and 3 inches, we'll want 14 feet or 16 feet or 18 feet and so on. And you'll also, the minimum width I believe is about 20 feet, and we don't want these to be any larger than 50 feet. So as you're modeling them, make sure that they fit within those general parameters. Other than that, the basic steps to making these, like this one I guess we can start on. It's pretty easy. It's just a cube, it seems. And so using the rectangle command, I just type in rectangle. You can click and make a rectangle or a polygon, or polyline, I mean. And then type in your units, which I'll be using 20 feet, but you guys may want to use other dimensions. And then let's switch to our perspective field. Well, first, I want to divide this into 4 pieces, because it seems that the general logics of this is that I guess it'd be 1/8 of this cube is redacted or cut out from it. So then from here, what we'll do is we'll extrude this curve by typing extrude curve, and what that does is it allows our cursor to lift that curve up to turn it into a volume. And then by typing in a unit, which because this is a cube, I'll type in 20 feet, and then enter, it will create a volume of a 20 foot by 20 foot by 20 foot cube. The next step, and real quick, change the layer of that so I can see that color. The next step is to omit this cube from the top, 1/4. So we'll again, selecting our lines layer, make some lines there, and then let's make another rectangle. This one will be a 10 foot by 10 foot rectangle, which we could just select like that. And then the next step is to extrude this curve such that it turns this curve into a 3D volume, and we'll extrude it 10 feet. in that direction. And now we have sort of all the armature geometry that we're going to need. From here, we'll type in Boolean difference. And now the command bar is going to lead us through some prompts to help through the command. And so it says select surfaces or polysurfaces to subtract from. So that's our input geometry, which for in this case would be the pink cube. And then you press enter once you have all the input. And then select surfaces or polysurfaces to subtract with. And now we will select this. And what we're left with, once we delete away that geometry, and I'll switch it to Arctic mode, is a 3D volume that looks pretty similar to the way that this one looks. Next, I'm going to take you through how to do this one, which again, even though it doesn't really look like a cube, I'll just, or maybe it is a 20 foot by 20 foot cube. It doesn't totally look like one, but I'll just use the rectangle we've already defined. And it looks like to me that this rectangle is extruded halfway up the cube that it sits within. And so we'll extrude this curve 10 feet vertically. And then next we have sort of this odd pyramid shape, which I think looks like this. What we'll want to do is we'll want to, in order to draw a line vertically, which will become a function that you're using quite frequently, you'll type in line, and then up in your options you'll select vertical, which will constrain that line in the z direction. You'll type in your dimensional constraint, 10 feet, and now we have this vertical line. In order to continue, let me change this layer real quick. In order to continue defining what this 3D volume is, we'll want to connect what is the height point to all the other corners in order to accurately reflect this geometry. And I want to remind you of two things as I am giving this pretty basic Rhino tutorial, that Rhino is it's a precision modeler, so you're always going to want to have your snaps on. So you see how there's this little tag that says end and intersection, and it like sort of highlights those lines that I'm connected to. That means that I'm connecting directly to this point. If I'm not doing that, the danger is that it's connecting to some other point, or it's connecting to some point like microscopically far away from the end of this line. So my geometries will be sort of broken and dirty, and it won't really work. So keep your snaps in mind. And the other thing is that most forms can be made as an armature of curves. So you see how I'm using these curves to sort of define the geometry before I even make it. That's something that I pretty frequently do that can be really helpful as you maybe think through ways of modeling something that is difficult to define or that can't be reflected with a singular command. This is something that can be done. And from here there's many ways that this geometry could be made. One way of doing it would just be to make, using this command, which is called surface point. So if you type in surf point, it will allow you to define a surface via 3 or 4 points. And because these are triangular, after I select my third point, I'll click enter, and that will make a triangular surface. And I could repeat that for each of these surfaces, and then I could individually select them and then join them via the join command. And then at the end of that, because this surface is still open, switching to Arctic mode to describe that a bit better. Because this is still open and we want to work predominantly with closed poly surfaces, we could type in cap, and that would allow us to close that. And now, when you select this, it says closed poly surface up in the top. Whereas before we capped it, it says open poly surface. So we could cap it, and then moving this volume back over top, we could then join these two volumes into one using the Boolean union command. And that fuses this into one singular poly surface. And in order to get rid of, we have all these vestigial lines everywhere. In order to make it visually look more the same, we could use the command merge all faces, or merge all coplanar faces. And that now makes this one singular, like this surface that was once a fusion of two surfaces is now one singular surface. The other way that we could have made this is by creating a rectangular volume. So I'll use curves and define another rectangle. And then we could have cut that volume with these diagonal lines. And I'll take you through the process of doing that. So what we'll want to do is we'll extrude this curve up 10 feet to make a volume. And then we will, using these curves, we will type in, we could either type in extrude curve, which to extrude this curve, this diagonal curve, and then using the direction constraint, we could define the direction we want to extrude that curve through. We would then, in order to cut this volume into two, we would type in Boolean split and select this surface to cut this into this thing into two pieces. And then we would repeat this extrusion and splitting process for the rest of those directions. Typing in Boolean split and then deleting the piece of the volume that we do not want. And then finally we would repeat this process once more, extruding this curve, typing in using the directional constraint. And then because this, like, sometimes it can get a little weird when you're splitting volumes, I oftentimes like to extrude my curves in both directions by typing in B and enter, or just by clicking this both sides toggle on and off. And then finally we'll type in Boolean split again, and then repeating the process of Boolean union and merging all faces to make this one singular discrete volume. So I guess Rhino sort of works, there's a myriad of ways that you could get to any one form, but we're almost constantly using the same basic commands, which are curve, extrude curve, and then the Boolean functions, Boolean union, Boolean split, and Boolean difference. The final geometry that we'll use, or that we're going to build, is this simple geometry, which is an extrusion of a basic shape. And I'm going to keep with the 20 by 20 rectangular constraint, just because I already have it here. And so there's a couple ways of making this curve unified so that we can extrude it. The first would be to do a polyline and then connect all the different points that we want. Select that line and then extrude this curve. We don't want both sides on in this case, so we'll toggle that off. And then we'll lift it. It almost looks like it's extruded 10 feet, let's say, 20 feet. Maybe not 20 feet. Let's go with 12 feet. 12 feet looks great to me. And it's a little bit off, but relatively close. For our purposes, it works. The next step, so now that we've worked through these various volumes and ways that you'll make them and different pitfalls that you're going to come across, the next step will be defining these grids. So what we're dealing with here, I have all these images sort of properly scaled. We need a 2x2, a 4x4, and an 8x8 grid. And this process will be relatively familiar to all of you because you've worked on line drawings extensively last quarter. But at this point, we'll just go through the process of line drawing. So I'll go through the 2x2 and then you guys can repeat for the 4x4 and 8x8. So I'm just going to use this one here because I think it's I sort of like it the most, I think. I don't know. Clicking in a corner after having scaled this image to such that the 2x2 is properly sized. And then typing in 2 feet by 2 feet. And then connecting these midpoints. I'm going to move it over here. The next step in this process is to offset the curve so that we have a thickness, because you can never, well, if you want something volumetric, you need a closed polyline to extrude to create a volume. If you just extrude an open line, such as this one, it'll just give you a single surface, and that won't be a volume. So what we'll do to establish that volume is we'll offset these lines. We'll want to always offset it inside the curve, because if we offset it outside, it would take it outside of the 2 foot by 2 foot requirement. And once we've typed in offset, we can type in our distance, which for this purpose is 1.5 inches. And we'll click inside. I get these little triangles up here when I offset inward. I'm not sure if you do. So I just make a rectangle that fits there, and then I delete this one to get rid of those. And then next, we'll offset each of these interior lines. You could offset it to one side or the other, or you could offset it half the distance, so 0.75 inches, and in both directions. And to toggle both sides, here you could click this, or you could type B and enter. And that would give you that, and then repeating for this. And now we have this line here, and then I'll just trim away some of the lines that I will not need. One thing that you want to keep in mind as you're drawing these curves is that we're attempting to describe something built out of wood. So what we're using is linear elements. So things such as a frame, like this, a 4-sided box, would be composed of 4 linear elements joined together. And so I'm going to draw in a miter joint like this between that, such that this is a single piece of wood, as is this, as is this, as is this, and together they make that frame. And then here, I'm just going to trim away that piece to create my frame. The final step of making these grids is we'll want to make sure that this piece of wood is a single closed polyline. Right now it's a collection of other lines, and so if we attempted to extrude this, the result would be less than ideal. I'll show you. Extrude curve. It would give us a bunch of single surfaces and then this solid closed poly surface. But what we would like is for each of these to be their own discrete volume. And so to get that, we'll highlight all the lines and type in the command curve boolean. And be careful to have your combine regions turned off. So we do not want it to combine regions. And then you individually select each of these regions. And now, if we move this over 4 feet, when you select each of these, each of them is a closed curve. And now, if we were to extrude, I'm going to be sure to group this here, and then changing my layer, I'll extrude it. And the distance we want to extrude for the 1.5 inch, or the 2x2 grid, is 1.5 inches thick. So extrude 1.5 inches. And now if you select each of these, they are their own volumes. The next step that I'm going to do, once I get that, I'm going to move this over 4 feet, and I'll group this frame. And this process will be repeated by you all for the 4x4 and 8x8. So you'll offset each side by 1.5 inches, but then the extrusion distance will be a little different. Alright, so now that you have, presumably, modeled and offset each of these frames appropriately so that each of them is just a collection of closed extrusions, linear closed extrusions for that matter. And bear in mind that if you do that properly, such that these are all linear closed extrusions, it will save you tons and tons of time at the back end when you're making your drawings. So I really do encourage that you keep that in mind and you, at this point, have everything modeled very cleanly. So the next step is to take your volume and these linear closed extrusions, grouped accordingly based on 2 foot, 4 foot, and 8 foot by 8 foot grids. The next step is to array them along the volume. So I'll begin rather arbitrarily, and keep in mind, I'm not doing a design project per se, so you guys should be doing this quite artfully and beautifully. I might be doing it rather brutishly, but my first step would just be to copy this frame, and I'll type in copy, onto this volume, like so. And now, there's a couple ways that one could go about arraying this frame or this grid all across the volume. The first would just be to copy it like a million times, and that's, I'm sure, more intelligent modelers than I would do it an intelligent way, but I would sort of do it like this. I would just move this thing. I would copy it, and then I would select all of these, and then I'd copy them again using this corner parameter point. And then once I got were I to get a large enough group like this, I would keep expanding my copy set. So now if I'm copying with a 6x6 grid of these 2x2 grids, I would now copy that whole sheet at once, and that's sort of how I would do it. But again, I'll go through probably a quicker way of doing that. But yes, I would do it like this. And then one could quite easily grab this whole thing and then move it off and type Alt to duplicate. And then move that to the back side like so. And doing it that way, one could pretty quickly, actually, adorn this whole volume with these grids, eventually getting to the point where we could omit the volume itself. I guess that would be better done if we were just to hide that. Another way to do this, I think, I'm going to move this off by a known dimension so that I can later bring it right back and group it so I don't have to worry about highlighting everything at the same time. I'm going to deselect that one. I'm going to move this -20 feet again. Another way of doing this would be the array command, where having this selected and typing in array, we could say, well, I want about approximately 10 in the x direction. I guess we have to define. So our x direction is, you can see it in this little readout down here. The x direction is going this way. So we want just 1 in the x direction. And then in the y direction we want, which is this direction here, we might want about 10, let's say. 2x2, 20-foot width, 10 would work. And then if our height is 12, we want 6 in the z direction. And now if we select this point as our origin point, it would allow us to select our spacing for our y direction, and then select our spacing for our z direction, and just like so, we would have accomplished the same task as the mindless copying. Array is a quicker way of going about it, but it's probably not the way I would have done it. I just would have copied, I guess, because my time isn't worth that much, I guess. So the next step in going about this, I'm going to move this back here just to get everything nice and pretty, and delete. The next step then is to begin mixing in these other grid spacings. And I think this is where your guys' pattern making skills come in. But I'm just going to mix it in, perhaps like so. I'm not sure I like that. Maybe I do. And then delete the affected grids that it's covering up. And without getting too much into this, just as much as is necessary, you can begin to imagine how this thing might be made up. And it's a decision to consider whether this aligns at the back or it aligns at the front. Both are valid, but have different advantages they lend to you. And then thinking about mixing these in as well. Maybe I want, let's see here, if I want to carry through, that won't do. If I wanted to carry through this diagonal here, I might want to place this piece here, like so, and then just fine-tuning to make sure that everything lines up properly. And I assure you, again, the reminder, if you do assure that everything lines up properly in good ways, it will save you time when you're making your drawings of this. And even though this is sort of unattractive, maybe it'd be more attractive if I did this. Maybe not. Oh well. Perhaps if I now rotate this, you can see how this begins to work. Trying to figure out the best ways of making it beautiful and consistent and have a pattern and whatever. And you guys will continue adorning this whole thing with a lovely pattern, but I'll probably stop here for the time being. The final step would be keeping in mind this corner or your different corner conditions. I think here what I would recommend doing is making another rectangle and then extruding that rectangle, extrude with the extrude curve command vertically, just so that eventually, when you delete this volume and are left with just your grid, and I'll switch to a different view mode, that corner is a controlled condition without this weird divot that makes the geometry inconsistent. Yes. So now the final step in doing this will be going to your cladding, which will be another series of linear elements which add another kind of language to the pattern that you've made with your grids of various sizes. And so I'll go back to this image here, or I'll go back to my sort of top-down view images, and the image that I'm going to use is this vertical black and white striping, and this is what we're going to use to make our cladding. Now, the motif of this will remain the same, but our spacing and otherwise will be different. The spacing that we'll want is we'll have one line, or we'll have, this line will be a member of 3.5 inches. Oh, I want to copy and paste that first. That will be a member of 3.5 inches. And then this will be a space of 2.5 inches. And that ensures that this hole, the member, or I guess the solid, and then the void will be 6 inches. And if we took this and we were to join this, and then copy that over, and now we could copy some more, like so, we would begin to create this kind of pattern. And then now selecting our larger unit, we could create a pattern like so. The great thing about this pattern is that now if we extrude it our 1.5 inches, I'm going to group it first, actually. Extrude curve, 1.5 inches, and now we have our basic volumetric pattern of members. If we deselect that, the curves, we can group these solid geometries and then place it under. I'm going to use the gold. Place it under there for our cladding. Now if we want to move this over to our grid, you'll essentially go through a similar process as you went through before with the grids and copy this on to your grid. One of the advantages of using a linear one is that using this scale one-dimensional tab here, which is the square tab on your gumball. Also, if you don't have this thing called the gumball open, you can just type in gumball and toggle on or off. I recommend having it on. So you can scale that one-dimensionally, or you could also, using the command version of that, type in scale 1D, then establish your directional parameter, and then you can scale that up to here, like so. And now we have, I'm going to ungroup this here, and I think I'll delete that one. And that gives us an idea of our basic patterning. And then grouping it again. Now perhaps I want to move it over here. These two walls are beginning to come to life as the pattern becomes a conversation between the cladding and the different grid elements. So that, I believe, brings us to the end of this tutorial. But if you have any questions or if I was unclear, please feel free to send me a barrage of emails. I'll answer them as much as I'm able to. And if my emailing skills aren't sufficient for you, please come to office hours and we could have a lengthier chat about these different things. And I can answer any questions that you have, or the other ISAs can as well. So I hope this was helpful. Have a great day.